Click the bell icon to get latest videos from Ekeeda.
Hello friends, today we will deal with the clipper circuit with bias. That is nothing but the bias potential I am giving on the circuit, and then we will have to identify what will be the waveform in the output of the circuit. See this circuit. First of all, we'll have to identify this particular circuit. In this particular circuit, diode is in between input and output in series. So it's nothing but series clipper. More than that, diode is oriented from input towards the output side. So it's nothing but the negative series clipper. So I'll just do the namakaran of this particular circuit. It's nothing but series negative clipper. Now only one change I made, that is nothing but the V1, that is external bias I have applied, DC potential I have applied, DC source I have applied, that is nothing but V1. Now if we say VO is equal to 0 volts, without this bias we have applied VO is equal to 0 volts for negative half cycle, because this is because diode D is reverse bias. So if we are applying this V1, then obviously this V1 will reflect the change in the output voltage VO. VO will become V1 for negative half cycle. So we'll understand this circuit in positive and negative half cycle. First of all, we will learn the negative half cycle and then we will go for positive half cycle. Then again I will give you trick just on the circuit and graph. We will directly plot the output waveform just by identifying this particular bias potential. Just do the operation of this, a very simple operation. First of all, we will learn the negative half cycle. Negative half cycle is straightforward. As voltage at this anode is negative with respect to cathode, obviously this diode D will become reverse bias in complete negative half cycle, right? So what we'll be getting in the negative half cycle, diode D will become reverse bias, right? As diode D will become reverse bias, it is ideally open circuit, and as this is open circuit, it is ideally open circuit. And now see the fact that diode is now open. I will draw this circuit over here. See this voltage is another DC source which is been given in the circuit, and due to that your output voltage will no longer as 0, rather than that it will give you the positive value, that is nothing but V1. So here we will say the value of VO is equal to V1. I will just make a box for this. So complete negative cycle will give you the output voltage VO is equal to V1. Let's come to the next point, the next part of operation, that is positive half cycle. The positive half cycle I will divide into 3 parts. Let us see why I am dividing this positive half cycle into 3 parts. This is my input waveform. And let us suppose this V1 is positive value. Let us see, this V1 is positive and my circuit is such that I am operating for positive half cycle. Keep this in mind that as I am applying this V1, right, so cathode voltage is nothing but V1, right, and V1 is positive value. So even though my anode voltage is positive but it is less than V1, diode will not conduct. So diode will become reverse bias when the input voltage Vi is less than V1. So this complete waveform I will bifurcate into 3 parts. Let us see here. This is first part, this is second part, and this is third part. For first and third part, situation is same. Input voltage is less than your V1. So we will say for first and 3 of figure A. Let us give this Namakaran as figure A. Okay, again we'll have to draw the output waveform as well. So for first and third of figure A, what will happen? Vi is less than V1. So we'll say Vi is less than V1, right? So V anode is less than V cathode. If this is the situation, then diode D will become in reverse bias condition, right? So here one change you observe that in positive half cycle, in complete positive half cycle, I'm not getting diode is in forward bias. In some part of the positive half cycle, I'm getting diode is in reverse bias condition. So when diode is in reverse bias condition, again the same thing I will be getting as an output voltage value. So VO will become V1. So here for first and third case, we will be getting VO is equal to V1. Now we'll have to understand what will be the value in the remaining portion, that is the second portion of the inputs positive half cycle. So in the second part of figure A, we will be getting Vi. Now Vi is greater than V1. So exactly opposite situation, Vi is greater than V1, and then your value of anode is positive with respect to value of cathode. Then diode will become forward bias, and now will give you the short circuit. As this give you short circuit, we can say input is same as that of your output. So output is following input for a part of positive half cycle, not complete positive half cycle. So this will be your output for positive half cycle. If we combine positive and negative half cycle, we will draw this combined waveform of the output signal here. Let us see, this is your V1. Okay, if this is the V1, we'll just project it on x-axis, and for this first and third part of positive half cycle, I am getting same value as that of your V1. In the negative half cycle, we also have got VO is equal to V1, so that will continue in the negative half cycle. So in the middle portion of the positive half cycle only, I'm getting the input same as that of your output. So this is actually the output waveform. All the negative part of the positive as well as negative half cycle is clipped off, which is well below the value of V1. So due to the bias potential application, I am getting the different waveform at the output side of the clipper circuit. In this way, I can change the polarity of the V1 as well. I can change the orientation of diode as well. So there are so many complex circuits I will be getting, but keep this in mind that if we follow the particular operation step by step, then it will be very simple to draw this kind of waveform. This will come for 5 marks in the first question of Mumbai University, that either they will give you this kind of waveform and they will say that identify the circuit and draw the circuit, or otherwise they will give you this kind of circuitry and they will ask us to form the output waveform. So Now this is the time to get the trick to draw the waveform just by getting the knowledge about the circuit without going for the operation in positive and negative half cycle. See, I have applied positive V1. That means the value of V1 is positive. So what I will do, I will just draw a line which is positive in between your positive half cycle and negative half cycle, that is V1. Okay, as V1 is positive, I will draw the particular valued line on the input cycle. Now what I'll have to do, I know that this complete circuit is nothing but negative clipper, right? So below that particular value, I will clip off all the input signals. So below this, whatever input signal I had, I did clip off, and I converted this complete AC signal into DC signal with a value V1. Very simple. If I have negative value, then what I'll have to do, I'll just place the horizontal line and it will intersect in the negative half cycle, and only this portion of the negative half cycle will get clipped off, right? So part of the negative half cycle will get clipped off here and will get maximum portion of the input signal. So this is how we'll have to deal with the complex circuit with clipper, and that too with bias external potential. Thank you so much for watching this particular video. We will learn more and more numericals with clippers and diode circuits, so stay tuned for that. Thank you so much. Subscribe this particular channel.